Hey everybody, welcome back to the developer track. Next up, we've got Darshan, who's founder and CTO of ScaleGrid. Sorry, Darshan, I'm mispronouncing your org's name there. Darshan's going to be talking about database as a service on CloudStack. So everybody, please give Darshan a warm virtual welcome. Over to you, Darshan.
Thank you, Giles. Hi, folks. Now, I'm, as Giles introduced, I'm Darshan. I'm the founder and CTO of ScaleGrid. And at ScaleGrid, what we do is we build database as a service solutions. And we handle both public as well as private clouds. In public clouds, we work on AWS, Azure, GCP. And in private clouds, we focus on CloudStack, OpenStack, and VMware. And essentially, when I say database as a service, our database as a service solution, the high level goal is that it handles all the operational aspects of running a production database: provisioning, high availability, disaster recovery, patching, upgrade, monitoring, alerts, and so on. The goal is database as a service handles all the operational tasks of running a production database, and you as a customer can just focus on the development side of things. And we have been doing this for well over 10 years now, and we have learned a few things along the way. This talk, it sort of had high level, it distills some of the architecture learnings from ScaleGrid and from our experience in CloudStack as well. Okay. The first thing I'm going to talk about is high availability. And so before I get into that, one general assertion, this talk is at a high level applicable to different types of databases, both relational databases, Postgres, MySQL, SQL Server, and also non-relational databases like MongoDB, Redis. But in this example, in this talk, when I have specific examples, I'm going to use Postgres as an example database. Okay. So the first thing we're going to talk about today is high availability. What typically high availability means for your database is that a loss of a single server does not bring down your database cluster. And this is typically a requirement for all production systems. And the way to achieve high availability is to run some sort of replicated setup. And in the case of Postgres, there are different types of replication. You can set up a master standby with the built-in Postgres streaming replication, or you can set it up with the new logical replication as well. And ideally, you would run like a 3-node setup, a master, standby, and a standby, giving you 2 replicas for your master. And if there is ever any issue with the master, and what happens is that there is a leader election that happens, and you have to use the framework depends on the database. Some databases have it built in, some you have to use external software. So essentially, when there is an issue with the master, the remaining nodes will elect a new master, and there is no downtime for your application. And when it comes to deploying these replicated setup on CloudStack, what we recommend is, essentially you want to distribute these replicas across different zones. So essentially, you want each replica to be in a different AZ. And the reason is, if there is any, hardware issue or if there's a failure of a single AZ, it will not bring down your entire cluster. Okay. Now, if you want to take this further, what if you want your database to be up and running, even when not just an AZ, but an entire region is down? And this is where we get into sort of DR concepts or disaster recovery setup. And before we dive into the details of how your database is set up for DR, I think the first thing to think about is, what are your requirements from the business side of things? When an entire region is down, what is the requirement of your application? Do you want the application to fail over seamlessly to a different region? Or is it okay for some downtime, some manual steps? Is it okay to rebuild the database from a backup? And I think it's important to understand all these business requirements because it's not just the database that has to fail over, it's all the other processes, the applications, the DNS names, the monitoring, all these processes have to fail over. And you want to make sure you're in sync across your application. And once you decide that you want to do DR, The best way to do DR is to distribute your replicas across 3 different regions, right? Now, why do we need 3? Again, the reason is the same as the HA we did with availability zones. Even if one region is down, we still want a quorum of replicas up so that a new master can be elected. And ideally, we would recommend like a 5-node configuration, 2 replicas in region 1, 2 replicas in region 2, and 1 replica in the 3rd region. This way, even if an entire region goes down, your database will still be up and function. Getting your DR setup right tends to be a lot more complicated than simple high availability. And the reason is, there are multiple reasons for it. And typically when you're doing DR, you're going across regions, and which typically tend to be in different geographies. And so network latency comes into play. So for example, when you fail over to your DR region, your network latency might be a lot higher than your typical region that you use. So that's something to take into consideration. Also, a lot of the underlying cloud constructs that you're very used to and comfortable with don't typically extend across regions. So for example, if you're doing access control using security groups, they don't really extend across regions. So you might have to do access control using IP whitelists, which can be, fragile and tedious. So in general, it increases the complexity and the cost. So when you're doing DR, you might want to get your requirements in order before you jump into any sort of DR implementation. The next topic we're going to talk about is performance, which is kind of the favorite bugbear of all people dealing with databases. And at a high level, databases are basically about RAM and disk performance. You want to use the most possible RAM that you can. At least you want to have your working set in memory. The more amount of RAM you have, the better your database will perform. So when you're choosing your service offerings, make sure you choose an instance type with the appropriate amount of RAM. And the same thing with disk. The faster the disk, the better your system will perform. So if you have a choice between SSD and non-SSD, you can choose SSD disks. Similarly, if your service provider offers IOPS, and if you're aware of the IOPS and the IO profile of your application, make sure you allocate enough IOPS for your peak load. And as our, you need to have the ability to be able to change the IOPS dynamically so that your system has appropriate IOPS for your peak load. Okay, changing gears a little bit. Let's talk a little bit about backups. Okay. Once your system is up and running, there are multiple ways you can back up your system. And at a high level, you can sort of segment them into 2 categories. The first one is logical backups, and the second one is sort of physical backups. Okay, logical backups are, like the name says, it's basically a logical dump of the system, and this can be using PG dump, Mongo dump, MySQL dump. They're all the same. Essentially, they will write out the data logically. And this approach works well when you have a small amount of data. But as your data starts to grow in size, logical backups will not scale. So essentially, you will have to switch to some sort of physical backups. And this is where, CloudStack platform has an advantage. With the volume snapshots that CloudStack provides, it's an easy way to implement full backups in CloudStack. And typically what we would recommend is to use a combination of full backups and incremental backups. For example, if you're talking about Postgres, what we would recommend is, you do your full backups with CloudStack volume snapshots, and you have a periodic job that backs up your transaction logs. In case of Postgres, it will be wall logs. So for example, you could have a process to back up your wall log every 30 minutes or so, and you could take full backups every day with volume snapshots. And there are some third-party options as well that are still based on logical backups. For example, if you're running Postgres, there are third-party tools like Barman, PG Backrest, and you can use these tools. They will use a combination of PG dump and transaction log backup to give you full backups as well as point-in-time recovery. Let's talk a little bit about your network deployments. Historically, most service providers or most cloud vendors, they were using a classic shared LAN. But nowadays, almost everybody has switched to a software-defined network or an SDN. It's the most popular one is VPC, and most cloud platforms support VPC, including CloudStack. And we would highly recommend that you use VPCs for all your deployment. And at a high level in a VPC, like an organization can define your own sort of network topology. You can define private subnets, public subnets. You can control routing rules between these subnets. You can add gateways. You can control how the routing works. So essentially, it gives you a fine level of control similar to what you have on your physical networks today. And if you're not using VPCs, we highly recommend that you should switch to this model. And databases, of course, you would want to deploy in a private subnet. If there is no reason for them to be accessed from the public internet, what we recommend is databases should be in a private subnet where they're not reachable from the internet. This dovetails into our next topic of security. So essentially, we talked a little bit about VPC, and in terms of your deployment target, if your database doesn't need to be accessible from the public internet, we recommend against giving it a public IP. It should be in a private subnet where it's not routable from the internet. And you should have the appropriate security group. You can use security groups to lock down the firewall. Access needs to be on a need-to basis. And this is particularly important if you have a database that is exposed to the public internet. You want to make sure that the firewall is locked down so that only your appropriate clients are able to access the data. Okay. Moving on to the next topic. So in terms of, there are a few other items in security that we should probably dive into. And again, depending on your domain and your application, this might be part of various regulatory requirements. And the first one is that you need to sort of have encryption in transit, and this essentially means that your data should be encrypted, whenever it hits the wire. And the way to do that is to use the SSL TLS support in your existing database. All databases should have TLS support. So, definitely use it. And this is particularly important if, your database is on the public internet and you're communicating over the public internet. Make sure TLS is turned on and all communication to the database is going over TLS. Okay. And the next important requirement that we typically see around, for regulatory compliance is encryption at rest. And what encryption at rest implies is that your data on disk is stored encrypted. It doesn't really mean that the data is encrypted in RAM or anything like that. It essentially means that your data at rest is encrypted. So if for some reason somebody steals your disk or they take a snapshot of your disk, then essentially it will be encrypted and they will be unable to access the data. And there are multiple ways to do encryption at rest, and various cloud providers support native support for it. And typically what we recommend at ScaleGrid is you can do OS level volume encryption. And for this, we use a popular Linux utility called Lux. It is based on dmcrypt, and essentially it provides like a volume level encryption. So essentially we encrypt the entire data volume. So all data that is being written to the data volume is stored encrypted. And once we do the encryption at rest for your data volume, if you implement your full backups using volume snapshots in CloudStack, then essentially your backups are encrypted as well. So for example, if you have an encrypted disk, and if you take a snapshot of the encrypted disk, and when you create a volume from the snapshot, that volume can only be mounted back on the original machines. So it essentially gives you like the security that your data is encrypted at rest and your backups are also encrypted at rest. Okay, and the next question is about scale. Now, once your database servers have been up and running for a little bit, the next requirement you will get is to sort of scale up your servers. And there are two types of scale. The traditional databases like Postgres, MySQL, they typically only support scale up, where you can essentially use a lot more cores, more RAM, faster disk, larger disk. But the more non-traditional databases like Mongo and Redis, they also support scale out, where essentially you can scale by adding new nodes. So if you're doing scale up, this model lends very well to the CloudStack model. And typically how we do it on CloudStack is that, we do a rolling scale operation. So essentially, let's say you have a 3-node Postgres setup. What we'll do is we'll start by taking down one node. We'll take down the node, update its service offering, updates the disk offering, bring the node back up, wait for it to sync up, and then move on to the next node. So this way, by doing a rolling operation, you are essentially doing like an online scale. And the only impact the database clients will see is a failover of master from one node to another. So a few other sort of maintenance operations I want to discuss a little bit about. If you're running a database, typically you are looking to upgrade your database, once or maybe twice a year. And this could be minor patch upgrades, or this could be major upgrades. And again, this is specific to Postgres, but most of the other databases will be similar as well. So in Postgres, minor version upgrades, you can do it in place. So essentially, it will be like a rolling operation, very similar to what we talked about with scale. And you will take down one node, you will upgrade the node, bring it back up, then you wait for it to sync up, and then move on to the next node. So essentially, you can do a pretty much online minor version upgrade. Major version upgrades in Postgres unfortunately require a little bit of downtime. So essentially, you have to take down all the nodes. You will upgrade the master using PG upgrade, and then you will bring up the standby nodes. Essentially, once the master is upgraded, you need to basically use rsync technique to basically update the metadata from the master and all the standbys. And because of this, there is, I would say, about a 5 to 10 minute downtime needed for any major Postgres version. Okay. The last topic I want to talk about today is monitoring. And once you have your production database up and running on CloudStack, you should make sure it is set up for monitoring. You should be monitoring all the OS metrics, from CPU, disk usage, RAM usage, network, and swap. This way, it sort of gives you a good idea of the load on the system. And if you see something concerning, you can intervene and you can make some corrections. And once you have the OS metrics monitored, you should also make sure to monitor all the database level metrics. For example, if you have Postgres running, you have to make sure that you're handling all the, you have the monitoring console which shows you all the inserts, the updates, the deletes, and the Postgres specific metrics, like what are the number of connections, what are the wall logs, what are the disk queues, what if you have replication set up, what are the replication delays. And it is imperative that you have this console set up to essentially manage all these aspects of your production database. And at a high level, those were the topics we wanted to talk about today. And if you have any questions, you have my contact info. You can reach out to us, and we're happy to have a further conversation.
Great, thank you, Darshan. Just one question at the moment. Dan has asked, do you maintain a CloudStack install yourselves for this to run on? I think, and actually I'm wondering this as well, what's sort of your relationship with CloudStack?
Yeah, so think of ScaleGrid DBaaS as a layer on top of CloudStack, okay? And our customers typically, they're already running CloudStack and they have relationship with CloudStack vendors. And so we don't help them with CloudStack. And think of us as a DBaaS layer, which they layer on top of their existing CloudStack installation. And you already have CloudStack, you have applications running, and now we want to run a database as a service. It could be for internal consumption, or it could be for external consumption.
Get it. So just sort of leading on to that, and there's another question related to this here. So do you have specific integration with CloudStack, or are you a layer that can go anywhere? And the reason I asked that is somebody's asked the question. I can see no mention of CloudStack on your website. Why is that?
There are quite a few platforms that we support, right?
Okay.
And we have specific implementations for CloudStack. So essentially, our integration is based on the CloudStack API.
Right. Get it completely. And then Harry has asked, any specific reason why only CloudStack over other services? I'm not sure I understand that question. Sorry, do you?
Got it. So here's what I would say, right? So at least here's what we are seeing from customers, right? Customers want to run like a cloud platform, and typically it's on their own hardware. And once they've decided to do this, right, they have multiple options, right? And typically what we see is people are running CloudStack, OpenStack, or VMware. So one of the three options, and as you're aware, and all three options have different sort of pros and cons. And a certain segment of population has chosen CloudStack. Historically, CloudStack was the first to the market. So they have quite a few deployments around the world. And once the customer has chosen his deployment platform, we are a layer on top. So we are not going to come in and change that layer. And we don't operate CloudStack. We just sit on top of existing CloudStack solution.
Yeah, okay. So in terms of, I'm sorry, this is just me asking you this, in terms of, you put that layer on top, are then people accessing ScaleGrid and your DB as a service through a sort of ScaleGrid UI, a ScaleGrid API, which sits on top of CloudStack, OpenStack, or whatever? How does that actually work? How do people go and spin up a database in ScaleGrid?
So we have two options for integration. So let's say you're a service provider, right? And see, one option is some of our partners, they basically take our API and they write their own UI on top. So customer is not aware of ScaleGrid. So customer just thinks they're working with a service provider. They will use the service provider's UI, and service provider internally uses the ScaleGrid API to essentially provision all the databases and do all the management. And we have another set of service providers, which they don't do the API integration, but they essentially expose to ScaleGrid UI to the customer. And the ScaleGrid authentication is typically sort of integrated with the CloudStack authentication. So once you're logged into your CloudStack account, you can do an integrated login to the ScaleGrid UI. Okay, once you do that, you can essentially provision your machines from the ScaleGrid UI.
Yeah, sure. And because we've got a little bit of time here at the end, Darshan, you did a really good job there of doing a relevant technical talk for our community, right? But you actually didn't tell us a huge amount about ScaleGrid, right? So I'd just be interested to know what ScaleGrid actually, as a product, as a technology, what it actually gives me, what exactly what problem is it solves?
Yeah, great question. So at ScaleGrid, what we do is we build database as a service solutions. And essentially, when I say database as a service, what I mean is our software essentially handles all the operational aspects of running a production database. If you want to run a production Postgres, production MySQL, production Redis, or production Mongo, so our software handles all the provisioning, the high availability, DR, patching, upgrade, query analysis, monitoring, alerts. And essentially the goal is our software and our support team will handle all the operational aspects, and customer can just focus on the development side of things.
Yeah,
so essentially, we give you a DBaaS layer, okay? And you can run it on your CloudStack system. You can run it internally in your own data center, or if you're a service provider, you can resell it to your customers as well.
Yeah, get it. So you're basically taking away the need for organizations to have DBAs. Your API will handle a lot of the stuff that traditionally that layer in an organization has done, right?
Yeah. So the way I would sort of present it is we don't take away the need for DBAs. We take away the need for certain types of labor, right? So essentially, the days of button clicking and deploying databases and manually setting them up, and if you look at sort of the Gartner reports, right, about 50% of the databases that are set up today internally are not patched correctly. And they're also very sort of inconsistent over time because, the DBAs come and go, organizations have changed. So what we ensure is, all the automatable tasks, that can be automated. Now with the arrival of the cloud, all those tasks for the databases are automated. You get a standard platform across your organization. All databases are deployed with the same security configuration. They're all patched and up to date. So we handle all those, automatable tasks. There is still the need for a DBA. The reason is, let's say, for example, you're having trouble with the schema, or if you're having trouble with queries, A lot of that still requires a lot of sort of human ingenuity and touch. So we cannot automate all parts of it. So the way I present it is we are changing what the DBA is focused on. Instead of focusing on button clicking tasks, he's focused more on the value added tasks of query analysis, schema analysis, and so on.
Get it. And then just one final question from me. Other people might be interested. Where are you guys based? Tell us a little bit more about ScaleGrid.
Right. So we are based out of the US, and we have 2 other branch offices as well. We are branch offices in Bangalore, India, and in Vancouver, Canada.
Cool. Okay, well, there's no more questions coming in. So Darshan, thank you very much. Everybody, please give Darshan a virtual round of applause and some thanks. Thank you very much. I found that interesting. Thank you, Darshan.
Yeah, thank you, Giles.